In this video, I want to continue our exploration of the world of mathematical proof. And more specifically, I want to look at a series example of a proof by induction. And I thought the best way to do this is just by looking at an actual question, because in the exam, you're going to get a question which is of this form, perhaps with different numbers and different expressions, but it's basically going to be exactly the same technique. So if you can understand what I'm doing here, and obviously I will talk you through it, but if you can understand what I'm doing here, you should be okay in the exam. Okay, so I'm going to look at question 8A of the January 2013 FP1 Edexcel paper. So let's just remind ourselves of the steps. Remember, there's 4 steps, a recipe if you like. If you follow this recipe, you should be okay. So first step is the base case. So in other words, proving it for the first number. You put a number in and you prove it for, if you like, your first domino, if you've seen my other video and you understand what that means. So we sub in n equals 1, and that is simple as showing that the left-hand side is equal to the right-hand side. So we sub in n equals 1 in the left-hand side, and we show that that's the same as when n equals 1 in the right-hand side. Okay, and therefore we're showing it's true. So the next step is assuming some general case. Remember, we call that general case n equals k, and we come up with an expression for the general case. Okay, so in other words, we look at our question, and whenever we see an n, we just replace it with k. So we come up with an expression for our kth case. We then go on and we look at our next general case, so the case after k, which of course is k plus 1. And again, we come up with an expression. We replace n by k plus 1. And then what we try and do is we also kind of come up with an expression which relates the k plus 1th case back to the kth case. Okay, and then we've got to show that those two things, the k plus 1th case and the case which is related back, the expression which is relating the k plus 1th case back to kth case, we want to show that they depend on each other. And that can be the kind of, the tricky algebra bit. That is, a word of warning with these type of questions, algebra is kind of the hardest part. Okay, but I'm going to talk you through the algebra, and the more you do, the more you kind of become familiar with it, and the more you become confident with it. And they always do fall out. They always do fall out. Okay, and it's, as long as you're good with the algebra, you'll be fine. And then the conclusion, well, that's just saying the right things in the right order. So here's what we were given. We're given from sum. This is the thing we've got to prove. We sum from r equals 1 to n of r times r plus 3. And you've got to show that's equal to a third times n, or prove that's equal to, I should say, because show and prove are slightly different things. Third times n plus 1 times n plus 5. So our first step is the base case. There is no shame at all, and in fact I'd actually advise it, in writing this down in the exam, writing down each step. So there's 4 steps, write a little heading and say base case. If anything, if that helps you kind of remember the process and remind you of the process, if you're sitting there in the exam and stops you from freezing, I'd definitely recommend doing it. But if anything else, I'd also recommend doing it because the examiner then can see that you've been thinking this through logically and try to lay it out in a logical order, and then they'll want to give you the marks. Okay, so the base case is the n equals 1th case, so all we just simply do is replace n with 1. And we consider the left-hand side and the right-hand side separately. So let's consider the left-hand side first. Let's consider this thing here on the left. So we've got the sum from r equals 1 to n, well, n is 1, of r times r plus 3. Now let's have a think about what this means, because, this starting from 1 and ending at 1, what do we do? Okay, so we sub in r equals 1. So we got 1 times 1 plus 3. And then we increase the counter at 1. But look, we're told to stop increasing the counter at 1. So in other words, we just stop at 1. This is what this top number up here actually means. Okay, so we've just considered the first case. We considered r equals 1, and then we're told to stop at 1. So that's it, we stop there. Okay, and this is equal to 1 times 1 plus 3. Well, 1 plus 3 is 4, so that's 4. Okay, so in other words, the left-hand side is equal to 4. Now let's look at the right-hand side. So again, we've got third times n, which is 1, times 1 plus 1, well, that's 2, times 1 plus 5, well, that's 6. Okay, so there we've got third times 1, that's 1, times 2, that's 2/3, times 6, that's 4. Okay, so we've got now that the left-hand side is equal to 4, but the right-hand side is also equal to 4. So we've got what we want. We've shown the left-hand side is equal to the right-hand side. So then we can just say, therefore, the base case, or n equals 1, is true. because we've shown the left-hand side equals the right-hand side, so therefore it works, it's true. Next step is our assumption step. So we assume that n equals k is true. So we assume that that case works. Okay, true. And we come up with an expression for that. So all we just simply do is replace n by k. So we've got r equals 1 to, there was an n here, so now we replace it with k, times r plus 3, times r plus 3. And that's going to equal to a third, well we had an n, now it's a k, times k plus 1, times k plus 5. Okay, and all I've just simply done is taken this thing which we had in the original question, and whenever I've seen an n, I've just replaced it by k. Now I want to do a similar kind of thing with what's known as the inductive step, if you want to call it formally. That is just simply the next general case, so the k plus 1th case. Okay, so I come up with an expression for the k plus 1th case, and all I just do, again, like I did with this n equals k, I just replace n by k plus 1 now. So k plus 1, r times r plus 3. And that's going to equal to, now, be careful here, I'd always recommend using brackets in your first go, unless you're really, really confident, and you know you're going to get right, use brackets. So whenever you had an n, just replace it with a k plus 1 now in a bracket. So I had a third. There's an n here, so I'm going to replace it with k plus 1 in a bracket. And then inside the bracket I had an n plus 1. Well, now I've got a k plus 1 in a bracket, plus 1. You can see why I've done that, because otherwise you may just look at that and forget to add that one. And then likewise I had an n plus 5. Well, now I've got a k plus 1, again, plus 5. Okay? So just do a little bit of simplification, just basically get rid of this kind of bracket inside a bracket, which I can do. Still got the third and k plus 1 out the front, here on the left. And now I've got k plus 1, we'll add another 1, that's going to be k plus 2. And likewise here, I've got k plus 1 plus 5, that's going to be k plus 6. So I've now got an expression for my k plus 1th case. But what I now want to try and do is come up with another expression which relates my k plus 1th case back to my kth case. Okay? And I'm just going to think about this very, very quickly. I mean, I know I have done other videos on this before, but I want to just really make it clear, just in case you haven't seen that. So let's just think about how we're going to do this. So we think in terms of summation, you know, what it actually means. So let's just take a really, really simple example. Let's take the sum from r equals 1 to 4. So I'm just using quite, ordinary numbers rather than k's and k plus 1s. And let's say this thing associated with the summation is the r squared. Okay, so the summation from r equals 1 of 4 of r squared. So what does that mean? Well, we put in 1 first of all. So 1 squared, 1 for r. Then we raise it, raise the r. So now we had 1, now we've got 2. So we're going to add that to our 1 squared. So we've now got 2 squared. And again, we're going to raise the r again. So we got now plus 3 squared. And then we're going to raise it again. We're going to plus 4 squared. Now we're told to stop at 4. So that's it. So this is the expression from r equals 1 to 4 of r squared. Okay. Now I want you to just look at this. These first 3 terms, I could choose any number of terms that I like, but I'm just going to look at these first 3 terms. That is the same as the summation from r equals 1 to 3, because we start at 1, we end at 3, of r squared. Okay? Why have I done that? Well, look. So now I can say that r equals 1 to 4 of r squared, the summation from r equals 1 to 4 of r squared, is the same as doing the summation of r from 1 to a number before 4, in this case it's 3, I can choose any number I like, of r squared, and then I just add the terms which I haven't evaluated in this sum from 1 to 3. So in this case I've still got the 4th term left over, the r equals 4 left over, so I've still got 4 squared, okay, left over. Now let's relate it back to our example. So we've got the summation from r equals 1 to k plus 1 of r times r plus 3. And I want to try and come up with an expression which relates it back to k. So I'm going to look at the summation from r equals 1 to k of my r plus 3. Well, what term am I going to have to add here to make this right-hand side equal to the left-hand side? Because at the moment it's not. I've stopped at k, well I need to keep going to k plus 1. So in other words, I've still got an extra term, and that extra term is the k plus 1 that I need to consider. So I need to put k plus 1 back into this r times r plus 3. I need to add it on. So I've got Now, r plus 3, I've just replaced r by k plus 1. So I've got k plus 1 times this r. Again, I'm going to use a bracket. K plus 1 plus 3. Do a little bit of simplification. That's the summation from r equals 1 to k of r times r plus 3 plus k plus 1. I'm going to simplify this thing. This k plus 1 plus 3. This is going to turn into k plus 4. There we go. So I've now got two expressions, the two expressions which I need. This is the expression which relates my k plus 1 case back to my k. Okay, and now what I need to do is I need to verify that my two expressions for k plus 1, remember what are my expressions for k plus 1? I'll write them down. So my expressions for k plus 1 is, first of all, the thing which I got up here, which is the third, k plus 1, k plus 2, k plus 6. Third, k plus 1, k plus 2, k plus 6, k plus 6. And I need to show that that is equal to the thing which I've just shown here. This summation of r equals 1 to k of r times r plus 3 plus the k plus 1, k plus 4. Okay. Well, I've actually got an expression for the summation from r equals 1 to k of my r times r plus 3. It's what I worked out in my assumption step. Look, that is an expression from r equals 1 to k. I've assumed that's true. So therefore I can use it. And that's a third times k plus 1, k plus 5. So now I've got a third times k plus 1 times k plus 5. In actual fact, there's a k in there. I forgot that k at the front. So third k. I've just made an error in copying that down. There's a k there. Plus, and I've still got this k plus 1, k plus 1, k plus 1, k plus 4. Okay, and what I now need to show is that this top thing here is equal to this thing here. Okay, so I need to show that third times k plus 1, k plus 2, k plus 6 is equal to a third k, k plus 1, k plus 5 plus k plus 1 times k plus 4. Hopefully I've fit that in. I think it might have just gone off the screen there. But I've just copied that down there. I need to show that those two things are equal to each other. Now, where am I going to start? If you're looking at this and you've got no idea where to start, do I start on the left-hand side? Do I start on the right-hand side? Always start on the right-hand side. And also, I would never recommend, unless you're really sure of what you're doing, manipulating both sides at the same time. I'd choose a side, manipulate that, and try and turn that side which you've chosen into the other side. Okay. Now, in this case, basically, always start with the side that's got the most terms on. The reason why is because this side, the left-hand side, has got less terms on. It's the more compressed version of this right-hand side. Okay, if it's true, of course, which it is, because I've done it earlier. So basically, I need to try and change this side into the left-hand side, and I do it by compressing. The reason why is, this side is the more compressed side. So it's a bit like saying, on this right-hand side, I'd have a 3 plus a 4, and I'd be able to compress that into 7. Whereas on the left-hand side, I'd have a 7, and it'd be difficult to turn that back into 3 plus 4, because I could also have 2 plus 5, or 1 plus 6. So it'd be a lot more guesswork on this left-hand side is what I'm trying to say. So let's just look at this right-hand side, and let's try and convert it into this left-hand side. I'm actually going to bring this, I'm not going to write it directly underneath. I'm going to bring it down here, so I've got a bit more room. So what am I after? Well, first thing which I want to take out is a k plus 1. Okay, because I can see that a k plus 1 is common to both these terms here. So I'm going to take k plus 1 out, and I'm going to use square brackets as well to kind of show a bit better what's going on. This is just kind of following your nose stuff. I'm going to talk you through it, but the more you do, the better you get at it. Okay, and I've still got a k plus 4 there. Now look at, it's always good to kind of compare back to what you want as well. Look what I've got here. I've got a third. I've got my k plus 1. That's good. But I've also got a third sitting out. Also got a third sitting with that k plus 1 as well. Well, I've got a third there, but here there's no kind of third there, except there is, because this is really just a 1 here. Okay, it's a 1 times something, but we don't bother writing that 1, do we? So I can convert that 1 into 3 over 3. Okay, 1 and 3 over 3, same thing. And then I can take that third from that 3 over 3 out, and I'll just be left with a 3 there. So let's take a third out of the whole thing. I've still got my k plus 1. Okay, taken that third out, so I'm left with k plus 5 there. And there's a k there as well, isn't there? Forgot my k again, sorry, in there. So there is still a k there. My apologies for that. Keep forgetting to k's today. And then I'm just left with my 3 here, because I've taken a third out of this 3 over 3. Or this 1, technically. Okay, hopefully you follow that. Now, what do I want to do? I want to convert this thing in the square brackets. I've got my third k plus 1, like I've got in this thing here. Again, I'm just converting, just looking back and seeing what I've got. And now I've got a k plus 2 and k plus 6. So I want to convert these things in the square brackets into this k plus 2, k plus 6. So, first things first, I'm looking at this. I want to try and expand this out. Okay, because the brackets, I always treat brackets as kind of like a barrier. They're useful sometimes to kind of partition things off. But if you're dealing with this and you're trying to manipulate it, get rid of brackets, because they're almost barriers. They block, your thought process. So this is, expand this out. This is going to be k squared plus 5k plus 3k plus 12. Okay. Do a bit of simplification. Third, k plus 1 still out the front. Do a bit of simplification of this thing. So we've got k squared plus 8k plus 12. Now I want to try and expand, factorise this now. I want to look for two numbers that add together to make 8 and times together to make 12. Okay, so I want third, k plus 1 still. What are we going to have? That's going to be k plus 2, k plus 6, isn't it? So when I factorise this quadratic in here, I'm going to end up with k plus 2, k plus 6. Well, if you look, that thing now is the same as this original thing which you've got. So I've basically shown that the left-hand side is equal to the right-hand side. So therefore, I've shown that my k plus 1th case depends on my kth case. That's exactly what I've won. I've just simply worked the algebra out, and I've shown that these two expressions are identical. Okay, in other words, my k plus 1th case depends on the kth case being true. So now my final step is just conclusion and just putting everything together. Okay, it's almost like putting a ribbon on the top of a parcel, on top of a present. Okay, just pulling everything together. And I'm saying things in the right order. So I've shown that n equals k plus 1th case, so my n equals k plus 1, or I should say when n equals k plus 1, let me start that again. N equals k plus 1 is true if being the crucial word, n equals k is true. So n equals k plus 1 depends on n equals k being true. Okay, if n equals k is true, then n equals k plus 1 is true. Okay, and I've shown that since n equals 1 is true, that's my base case. I've shown that works. So I've shown that n equals 1 is true. Then it is true for all n greater than or equal to 1. Okay, with n being positive integer. That's all there is to it. Okay, this thing here is basically, if you just commit this to memory, if you understand what's going on like I do, I don't commit this to memory, I just remember. But when you keep writing it out, it kind of just flows out. But yeah, basically the hardest thing in here is the algebra. The basic steps and stuff, if you follow my recipe, you'll sort it. Okay, anybody can get the first mark, the base case mark. Anybody can just put numbers in. It's the algebra that's kind of the trickiest bit. But even so, if you can still show that you've tried to relate k plus 1 back to k, and then even if you just put the conclusion down to show that you understand the basic process of, what proof by induction is all about. And there you thought you should be fine in the exam, even if you're not that good with algebra.